Okay guys, before starting the video I would like to thank who subscribed my channel and who liked my videos, and special thanks should go to Prexter 1.6 and Kishore Kaniti and Ankit Keshari for inspiring me to do this comprehensive explanation. So first question is cyclic binary string. So here our target is, here we are given a string, a binary string, and we can cyclically shift this string at any number of times, and then let x be the decimal representation of the string s. So our target is to find the greatest power of 2 with which x can be divisible with, and if it can be divisible with any arbitrary large power, print -1. So let's take this example. So without no shifts, the decimal value of this string is 274. So this can be divisible by 2 to the power 1. That's it. We cannot divisible by 4, 8 or anything, any other power of 2. So the answer is 1. So when we shift this by 1, we get the decimal value as 137, and this is not divisible by any power of 2. It's only divisible by 1. So the answer is 0. That is 2 to the power 0 is the 1. So when we shift again, we get the 324 as the decimal value, and the answer is 2. Here you can observe the pattern. When we have 1 zeros at the end, the answer is 1. When we have no zeros, the answer is 0. And when we have 2 zeros, the answer is 2. And this pattern repeats. So what we have to do is, we have to count the maximum length of consecutive zeros. So that is the answer. So if we take this example, for any shift, the string is the same and the decimal value is always 0, and this can be divisible by any number. So the answer is -1. And if you take this example, and if you count the maximum consecutive zeros, you will get 3, but when we shift 7 times, we will lead into this string, and it has 4 consecutive zeros at the end. So answer is 4. So in such a string, we should find the starting sequence of zeros and the ending zeros and add them together and check whether it is the maximum. Check my solution video for the code, and the next one is game of maximization. Here they are saying there are n piles of stones, where the ith pile has ai stones. You need to collect the maximum number of stones from these piles, but you must fulfill the following condition. The condition is the piles from the odd places should be equal to the piles from the even places. So let's take this example: 4, 1, 4, 5, 6, 7, 3. So if you get the sum of the odd positions, we will get 17, and if we get the sum of even positions, we will get 13. So from the odd positions, we only can get 13. So the answer is 26. Here what we can do is get the summation of even positions and the odd positions and get the minimum value out of these two summations and multiply it by 2. If both odd and even are equals, then we can multiply any value by 2. The next question is strictly increasing sequence. The question is, in a new number game, players are given an integer array of length n. The players take turns. In each turn, the current player does the following. The task 1 is, if a player can reorder the array elements to form a strictly increasing sequence, they win the game. So note that here he has to reorder the array to form a strictly increasing sequence. So here what we have to determine is whether the player can reorder it to form a strictly increasing sequence. So to form a strictly increasing sequence, the numbers in the array should be unique. And then we don't need to reorder, we just need to verify that the numbers in the array are unique. And if the player cannot create such a sequence, then he's going to remove one element from the array. So let's take this sample example star, and I consider this as the base case of this question. So if you can give your opponent this kind of sequence, then he has no option. The only option he has is to remove one element from the array. Then you are going to definitely win the game. Right? So your target is give your opponent this kind of array. So you should remove elements to create such an array. And take this case like if you get the array with all the elements are unique, then nothing to process. The first player will be win. So let's take a different example where there are duplicate values. So according to the previous one, this one, so your target is to create a array with two elements, array with two identical elements. So here to create such elements, there are 8 elements in this array, and so you should remove 6 elements. So if you play optimally, this is what you should do. So if the sequence has even number of elements, then after the even number of steps, you will lead into this kind of array. So if the sequence has odd number of elements, then you will have to remove odd number of elements to get this kind of array. So if you are given this kind of sequence and the number of elements in this array are even, then this second player will win. And if the number of elements are odd, first player will win. To check out my solution video for the explanation and the code, actually not for the explanation, for the code. And the last, here you can see how it happens. This is the given array, and then first player will remove this 5 or some element. I take this, he will remove this 5, and then the second player will get this sequence, and again he will remove 1 5, and the first will receive this one, and he will remove the other 5. So after that point, the second player cannot remove any 4, then the first player will win. So he will remove 1. This pattern repeats until you get to this point 4 4. So after that, first player has to remove 1 4, then second player will win. So next question is the RGB queries. Most of the people found this is very difficult or bit difficult. So the question is, RGB color is formed by adding different intensities of red, blue, green colors. So any RGB color can be represented in the form of triplet RGB, where is intensity of color red, N denotes the blue color, and I think this is incorrect, where R is intensity of red color and G denotes the intensity of blue color, and G denotes the intensity of green color, something like that. Read the question from the HackerRank. This is wrong. So you have been given n colors, where each color has the intensities of red, blue, and green colors such as R1, G1, B1. So you can make new colors by mixing subset of these colors. So if you mix colors R1, G1, blah blah blah, then you will get a color having respective intensities of red, blue and green, such as the algorithm of adding or mixing the colors is get the max value of R and max value of G and max value of B. So let's take the example 5. We have to create 5, 4, 3 from these set of colors. So since it takes the max color, so any color we mix can have the 5 as the maximum value for R and 4 as the maximum color of G and 3 as the maximum color of B. So here we have two colors with 5, but if we take these two colors, our G value becomes 6 and B value becomes 6. So we can't use these two. So if we use this one, then our red value is 4 and again G value is exceed the value, so we can't create this color out of this set of colors. So in the other example, actually we don't need to mix, we can use the middle one. So if we use this color, we get the expected color. In the last example, so here we have to mix all the three colors, then for the max value of R is we get 5 from 5, 1, 1, we get 5. For the G we get 4 from 1, 4, 1, and for the B we get 3 from 2, 2, 3. So what we can do is we can store these colors as a map. So when we store this color, we will keep 5 as the key and this color as a value. Here our map is a list of maps. So we have a color list against this number. So for the 5 we have 2 colors in our list. So if we need to create 5, 4, 3, we should only consider the values of which the red element has 5 and green element has 4 and blue element has 3. So we have to consider only these values. The other values we don't need. And so we create 3 maps, one for red, one for green and one for blue. In the red map we store the colors against the red number. So if we store this one, we will get 2 map entries for 5 and 4. Against 5 we have 2 elements in the list, and against 4 we have only 1 element in the list. And when we process this list of 5, we should consider the other 2 colors, green and blue, should not exceed the expected values. If it exceed the expected values, we can't use that color, because if you use that color, the mixture gets the maximum value, so it gets this value. So we should go through the list of 5 of red and list of 4 of green and list of 3 of blue, and we should identify or verify we have found at least one color which has R segment as 5 and other 2 segments less than or equals to the expected values. So it is the same for green and blue. If we can all the 3 colors, so then we are done. Then we can print yes, we can create the color. Otherwise, if we cannot see any value against 5 in the list, then no, we can't. For against the green, if we cannot see any value, again no, we can't. And against the blue, if we cannot find any color with 3, against we can't. So this is the algorithm and this is the idea. So check my solution video. So it will get you some idea now. If you have questions, please comment below, and thank you very much. And if you get any help from this video, please you can help me back by subscribing my video and subscribing my channel and liking my videos, and also sharing my channel. And thank you. Let's meet with some other questions.